Hi, welcome to our video lesson about the range of functions. Just a reminder before you watch this video, please first watch the video about the domain of functions. So for now, when we solve for the range, you must find an expression for x in terms of y. However, you must always refer to the original equation to check the derived values for the range. So I'm going to give you a few examples for the different types of functions that you will encounter in this lesson. So the first one that we have is this: y is equal to 3x plus 2. This is an example of a linear function. So a linear function is a function that can be written in the form y is equal to ax plus b, where a is a non-zero real number. Okay. So for every linear function, its range is the set of all real numbers. Or we can rewrite it as in set builder notation, y such that y is an element of the set of real numbers. So unless stated otherwise, this is the range of any linear function. Next, so let's have our next function here. We have to find the range of the function f of x is equal to 2 over x plus 1. So if we have a function like this, a ratio of algebraic expressions or polynomials, then this is what we call a rational function. So a rational function is a function where we have polynomial numerator or denominator. So for rational functions, we always take care or take a look at its denominator. But since we are solving for the range, we have to rewrite the expression first. So originally, what we have is y is equal to 2 over x minus 1. So from here, we need to isolate x instead. So what we're going to do is we're going to multiply x minus 1 on both sides. So once we multiply, this cancels out, and then we can get x minus 1 times y equals 2. Then from here, we need to expand this. So distribute y, x times y, xy minus y equals 2. And then from here, we need to isolate all the terms with x on one side. So this one goes to the other side. So that's going to be 2 plus y. And then now that we've isolated all the terms with x, if we have more than one term, we need to factor it out. But since we only have one term with x in it, then our next step is to divide everything else, uh, the every other values together with x. So in this case, we only have y. So we divide both sides by y. So this cancels out. So we have now written x in terms of y. So that's x equals 2 plus y all over y. And then once we've done this, then the process for getting the domain is the same now for getting the range. We look at the denominator. So the denominator is still not allowed to be 0. So here, the denominator, we only have y. So y should not be equal to 0. Okay. So our range from here, range is any value of y that isn't 0, or y such that y is an element of the set of real numbers and is not equal to 0. That's how we get the range for rational functions. Next, let's have quadratic. So we have y equals 3x squared minus 4. So we can still do the same. Rewrite the equation in terms of x. So we can transpose, again, isolate the terms with x on one side. So we want to transfer negative 4 to the other side. So we get y plus 4 equals 3x squared. And then everything else, everything that's multiplied with x has to be removed. So we're gonna divide both sides by 3. Then from here, we got y plus 4 all over 3 x squared. And then to solve for x, we need to get the square root of both sides. So this cancels out. Square root of x squared is just x. And then from here, don't forget that whenever we get the square root of both sides, we have to consider its positive or negative values. So that's positive or negative square root of y plus 4 all over 3. And then from here, just let me write it down, quadratic. Okay. And then from here, what we actually have is a radical function, right? So for radical function, our requirement is that the value inside the radical should be greater than or equal to 0. Greater than or equal to 0. So we're going to use that here. So the value inside, which is y plus 4 all over 3, as you can see here, should be greater than or equal to 0. And then from here, you need to solve for y. Divide both, multiply both sides by 3 times 3 here. So we get y plus 4. This cancels out. And then we have 0. Solve for y. 0 minus 4, that's negative 4. So our range is that y such that y is an element of the set of real numbers and is greater than or equal to negative 4. Okay. Next, for our next value, we have, or next function, we have y is equal to 5 minus x squared. You can pause the video if you want to try it yourself. So we have another quadratic function. We can rewrite it first. So isolate x. So transpose 5. We get y minus 5 equals negative x squared. Remove everything that's multiplied to x. So we divide both sides by negative 1. So that gives us, so here y, we can divide both of these by negative 1. So that becomes y divided by negative 1 is negative y. Negative 5 divided by negative 1 is positive 5. And then this just cancels out. So we get x squared. Then from here, we can get the square root of both sides. So we know that positive negative y plus 5 can also be written as 5 minus y. So either way will be just fine. So square root of x squared, that's x. And now we have another radical function. So we need to make sure that the value inside is greater than or equal to 0. So we write 5 minus y is greater than or equal to 0 and then solve for y. Transpose negative 5 or subtract 5 on both sides. So that's negative y is greater than or equal to negative 5. We're solving for negative or for y, the values of y. So we divide both sides by negative 1. That gives us y and then 5 here. But just a reminder, if you are multiplying or dividing a negative value on both sides of an inequality, you have to switch the inequality. This is from greater than, we have to switch it to less than. So that is because of the multiplication property of inequality. So please pause the video and I study the property in case you've forgotten it. But basically, again, if you're multiplying or dividing a negative number on both sides of an inequality, you need to switch the inequality. Okay. So the answer, our range is now y such that y is a real number and is less than or equal to 5. So that's how we solve for the range. Next, finally, we have radical functions. So for radical functions, so let me write the name or the type first. So I'm going to show you my process. I already have rewritten the function in terms of x. So this is what it looks like. Wait a sec. So you may also try it yourself, but when you rewrite it, it's going to give you a quadratic function. So this is the result. So for a quadratic function, we don't have a necessary restriction, unlike for radicals and rationals. So you need to revert back to the original function. So this is what we are pertaining to when it says that there will be times that you need to look back at the original function. So let's look at the original function. We have y. Again, we don't have a restriction here. So we need to also check the original function. Okay. So from the discussion of domain, you know that the values inside should be greater than or equal to 0 or a non negative number. Okay. So if you get the square root of any value greater than or equal to 0, then the result is also greater than or equal to 0, right? So for example, if we have, if x plus 5 is equal to 1, then square root of 1, we get the square, this is positive, right? So if we get its square root, it's just equal to 1. So it's still a non-negative number. Okay. So you can plug in any non-negative value. If you get its square root, the result is also non-negative or greater than or equal to 0. But then you need to get or multiply whatever result you have to -1 because we have a negative here. So any number multiplied or any non-negative or any number greater than or equal to 0 multiplied to a negative value or -1, that will give us a number less than or equal to 0. Okay. Or non-positive. Okay. So again, let's have these different scenarios. So let's first have x plus 5 is equal to 1. Let's also have x plus 5 is equal to 0, the minimum, right? And then x plus 5 equals 100, for example. So if you don't need to do this, I just want to show you why it's like that. So let's plug it in. Y is equal to negative square root of x plus 5. So if we substitute, we know that x plus 5 is equal to 1 because, again, the numbers inside should be greater than or equal to 0 only. So this is 1. Square root of 1 is 1. But then we need to multiply it to negative. So the result is -1. Here, y is equal to negative square root of x plus 5. We, in this scenario, x plus 5 is equal to 0. Square root of 0 is 0. So -0, that doesn't exist. 0 is neither negative nor positive. So the result is still going to be 0. So these are the possible values of y. So next, y is equal to the same thing. The value inside is 100. Square root of that is 10. But then we have a negative. So y is equal to negative 10. So no matter what allowed value of x we have, the result of y will always be 0 and below. Okay? So our range is the set of y such that y is a real number and is less than or equal to 0. So that's how we solve for the range. If you have any questions, please just put a comment or send me a message together with the timestamp. Okay. So for exercise, please pause the video and try to get the range of these following functions. Okay. So I hope you tried getting the range of these functions. I'm going to put my solutions here. So please pause the video if you want to look at each solution that we have. So for our first function, it's the set of real numbers, as you can see here, because it's a linear function. For our second one, it's a rational function. So I'm gonna put everything here. So we have a rational function here. Okay. So this is the solution. If you have a specific question about these, just let me know, okay? And then so from here, um the range is any value of y, any real number where y is not equal to 1/2. For the third one, radical, so that's greater than or equal to 0. And then we have a quadratic here. So the range is y greater than or equal to -8. Okay? So that concludes our lesson about range of functions. Again, if you have any questions or any comments, or if you noticed any errors here, just let me know. Okay? Thank you so much.